Under 9.2 on page 179, you can use tables to find the value of z given a probability. Before we go there, it is important to understand some information that is bolded there. The table of percentage points of the normal distribution gives the values of z for various values of p, and it gives us when the probability of z is greater than z. Please note that this is the table. This is the table of percentage. It is already in page 202. I'll show you how to use it. And it is important for anybody to note the following, that by symmetry, if we say that the probability of z greater than 1.2816 is 0.1, and diagrammatically this is represented this way. Of course, greater than is 0.1. Remember, we said that the whole model, the area of the whole model is actually 1. So 1/2 of the model, the area is 0.5. And you can see if the area is 0.1, then we have 1.2816. We are talking about that area. We are talking about that region X. It is the region that is actually equals to 0.1. If this is given, it is also important for you to do by symmetry. There is another negative 1.2816. And this region is also equals to that. Please note that if we have this, then it follows that the probability of z less than negative 1.2816 is also 0.1. Note that from 0 to the left, our values of z are negative by symmetry. Whenever possible, this table should be used to find z given a value of for p when z is greater than z. That is the percentage table, page 202. I'll show you how to use it. Before then, it is important to underline the following, that if the probability of z less than a, where a is the boundary, is greater than 0.5, we can have a small model of something like this, less than, and it is greater than 0.5. That means it's greater than a half. It's this way. So a is here. Then a is greater than 0. A is always greater than 0. You can see a is on the right. And if there is a probability of a certain z less than a, where a is the boundary, it's less than 0.5, and probably we can demonstrate it this way. The area is less than half, and we are talking about the left hand region. That means it is not yet half. Our a is here, so a is a negative. Then a is less than 0. Very important for anybody to note that. And if there is the probability of a certain z greater than a, where a again is a boundary, and it is this one is less than a half, and we can demonstrate it this way. Something greater than, and it is less than half, then we are talking of this particular region, that one. Then already you can see if it's greater than a to the right, and the area itself is less than a half in the second half, then a is greater than 0. You can already see it's greater than 0. And if the probability of z greater than A is greater than 0.5. That means when you're talking about the right hand region whose area is more than a half, which can be demonstrated this way, the right hand side whose area is more than a half because of greater than, then you can see where it dwells. Then A. This is very crucial information. That is very crucial for anybody who is studying numbers future. And I think that is just like it, and we will be able to use this one in example 2. Please take note, and I may not even rub what I have here so that we can understand example 2 with ease. Okay?